Let's go over the fourth week for imperative programming. There's no third week because just wasn't lecture in that week. So let's go over that. In here we have module, basically just a bunch of definitions in this chapter. And it's kind of just like knowing what the definitions are and how to differentiate what is what. We start off with just module. Module is just small manageable chunks of code. So the idea behind this is, okay, yeah, we don't want like a whole long wall of text. We kind of want to break it down into manageable chunks. And then here it's code decomposition or modularity is basically the idea that complex systems are composed of modules and that each module should play a single well-defined role. So that means that there's a spec like each one is like something unique and just something that is needed. And then the second part is abstraction and encapsulation, which basically means that components can be viewed as black boxes. So we don't really care about how they're implemented. So um, as long as it works based on its description, we're fine with that. And then reusability, basically the idea that it can be reused for multiple scenarios rather than just for one instance. And here we just have modules separate the interface from the implementation. So interface in this sense describe what the module does. And implementation is the actual code that does the what is promised, right? So yeah, module separates interface from implementation. And then next, what we have, the concept is functions can be seen as a form of modularization. So for functions, we have the interface, which is basically like the signature of it, such as types of argument, result return, pre and post conditions, things like that, right? Just like the specification in general. And then our implementation is basically just the local variables used to implement the algorithm, right? So yeah, so that's interface and implementation. Interface, abstract definition of promise of what you're going to do and what's involved. Implementation is actually doing. In object-oriented languages, modules are objects and classes. So object is basically a software artifact with data and operations. It has a specific public specification or public interface that describes what its operations do and has implementation of it. And data is private to the object. So for instance, we can do something like this, object dot, and then something, some sort of operation with some sort of argument. So yeah, for this current object, we can just do this dot op, some kind of operation args. And the next what we move on to is just talking about what OOP stands for is object-oriented programming. Pretty straightforward, I'd say. And then we have multiple instances of a class can have separate identities. Um, yeah, and the aliasing is just a term to describe the fact that we're just going to copy objects, identities, without copying the objects. So, for instance, let's just say we have a var something of like, let's say vector int or something like that, and we don't want to go through that. We can just define it to be px, and then we can just and it's just called aliasing. It's just that we just define it to be another name. And then here we have things like we have the external interface. So that's basically telling us what does the thing do, right? And then the internal implementation, so how we actually implement it. So this is not in the interface, it's private, and usually it's inaccessible because we don't want people to see how we actually do it, right? So that to prevent like to be safe. And then guess there's just another concept as two objects in Scala. So there's singleton objects, which are created without a corresponding class and used to hold utility methods or values that are global to the application. They're defined using the object keyword followed by the object name, um, object names. And then there's also the second type, which is standard objects, which are created from a corresponding class and used to represent instances of that class created by using the new keyword followed by the class name. So For instance, here we could have a standard object, which would be a local variable. We would just have something of new, and then let's just call it array inset, and then we initialize it to have 10 values. Or we can do something that is a singleton object, which would be global. Then we would just have object and then some kind of name and then whatever thing that we want inside. So yeah, so that's the difference between singleton and standard. Next is just kind of talking about inheritance. Inheritance can be thought of as a relationship, which is kind of rigid. We have some kind of class, extends from a parent class. So that's the idea. We then have overriding method, which basically talks about like if there was already a method that was defined earlier, we can override it with our new version with just the keyword override. And then there's the concept of dynamic binding, which basically decides which version of a method to execute when inheritance is involved. So if there were multiple methods, then dynamic binding would figure out which one we do. Um, and the next what we have is, I just wrote something like this. We could just define it like this. Something of value t is a type of text, and then we're just going to do new plain text. So we just have a static type text defined, right? We explicitly declared it over, we get the thing, we specifically declared it over here, and it's just because we did it, it's going to be a static type. And then we have the dynamic type, which I'll just use this color we have over here. Dynamic, we just did new plain text. So for that, this is the actual object created in memory. So yeah, so we can think of it as whatever is on the right-hand side over here that we actually is the thing that we create. And we're just going to wrap it inside the static type that we define to be text. So that's the idea of what this kind of one sentence means. And then just a side note is that inheritance is sometimes dangerous because, for instance, if we have like a um, not so good base case and then we change the parent, and then this could potentially kind of have a chain effect on its kind of children who kind of rely on it, right? So that's the idea. And there's a different relationship other than the is a relationship from inheritance. There's composition, which basically is a has a relationship. So it allows us to create kind of um, more, let's just say, interesting types by combining objects of other types. And that's just basically it. I think here it's just some abstract data types. Basically, abstract data types give the generic description. A state refers to what is represented. Um, init gives the initial configuration of state and pre-post conditions on operations. And trait gives the interface of what a module should do. Basically, in other words, it's just a list of promises that must be fulfilled later. So yeah, this is a pretty important thing that is often asked in problem sheets that we're asked to do is just kind of give what the abstract data type is. And then it's important to kind of know what is the state and what is the init, like the conditions and other stuff. And yeah, traits are just promises of what of the interfaces. Here we just have an example of the code. We have a trait which we call inset, and our inset is an interface. So we're just going to basically say, okay, we have these functions that we're going to define and implement later. Um, and then we could have a class called A set or B set. It extends from inset. So this would be kind of our parent class. And then we would inherit some of the properties of these functions from there. So yeah. And then talking a bit more. Okay, we're almost at the end, but I think, yeah. Mix in composition. So mixed in composition basically means a class can kind of extend multiple traits. Um, a trait mixed in last takes precedence if it has the same name. So idea is that, okay, traits are just things that could have certain properties, right? So we can definitely get a mixture of multiple traits, right? You can just get multiple. And if it's the same, then the last one, the most recent one, will take precedence. And here is just kind of just going over before some of the things that were kind of um, the difference. So field is basically can be treated as the data, the method is kind of like the action. Abstract means that we're just kind of throwing the idea out there and just saying what are the functions we're going to do, or are kind of their states, conditions, stuff like that. And then the concrete stuff is actually like the code that we actually use to implement it. So yeah, so that's the differences. Then we have traits can have abstract and concrete methods and fields. Yeah, that's what I mean by earlier methods and fields. Fields is data, method is action, kind of like that. Interfaces only have abstract methods and fields. Trait cannot have instance variables, so cannot maintain state. I think this is kind of like interesting and kind of key to remember is because um, yeah, trait is kind of like the generic type, right? You can have abstract, concrete, you can have methods, you can have fields. It's kind of like open up to all because trait can be anything. Interfaces, because they're just promises of what we're going to do, right? So it's abstract. And then it could be methods and fields as well. And then trait cannot have instance variables. So that's kind of like something that's often tested is um, not having that, so it can't maintain a state. So yeah, below is kind of okay, I'm not done anytime soon. So I have below I have the trait, which is just an example of the things. I have the trait greeter, I have the definition of the name, which is a string. I have the function def greet. Basically what it does is just print the name. So then I can just say I can have a class which I call person, which takes in a name. And I know that extends from greeter. So I have this trait, right? And then I can just create a person, which basically I do new person Alice, and I'm going to do val p. Because person extends from greeter, right? So then I can have access to the greet function. So I can just do p.greet and it would print out hello Alice. So yeah, that's the idea, is that we can have first the trait, then the class, and then the extends. So then we have this access to the trait, then we can have access to the functions defined inside, and then the name would just be whatever that was put in. And yeah, I kind of drew here that sets can be both mutable and immutable. Like it depends on what you want to use, right? So if you do val s, so val basically means it's immutable. So we just have, but over here you kind of say it's mutable. So then you can have access to functions like add, contains, size, which are just adding to this thing. And then you can also have mutable hash set. Um, and you can have mutable map. Um, and then for map, there are some specific functions like apply with some key or update or contains. These are just mainly some functions that are pretty useful, say in general. And then if you just do something dot apply, it just basically means calling it with that parameter. So for arrays, we can see that, okay, yeah, we don't usually do dot apply. We just straight do something and then the brackets access it. So that's basically what's happening in the background is that we're just calling O dot apply, but we just write this, which is equivalent. And the next what we have is the concept of wrapper. So a wrapper is just a design pattern that kind of take an existing class or data structure and enclose, which we call wrap, it inside a new custom class. So below I kind of included a kind of code. We have something called object map book extends book. And then we have a private, we define private stuff. We have a definition. So the wrapper over here would be the MacBook object. And the wrapped object would be the standard scalar map stored in the private internal variable map. So it'd be over here. And then we have something like this. We could do val book 1 equals new MacBook. Val book 2 is equal to new MacBook, so on and so forth. And each one would be independent and has its own kind of state, right? Because we can have some kind of thing going on. So that's the idea. I think overall, the main takeaways from this was just a bunch of definitions and knowing what each term means. And on top of that, just kind of getting familiar with like the inheritance, composition, kind of the idea that there's binding that is static and dynamic. Also, abstract data types require state and initial conditions. What else? Yeah, traits. Doesn't trait is kind of like has both abstract and concrete methods and fields, but that cannot keep state. And yeah, some other useful things like sets, hash set, map that are useful for Scala that should be used more. And then finally the last part is just the wrapper, which is just like having the wrapper, the wrapped object, and then each one is kind of in its own independent internal state. That wraps up this chapter, I'd say. A lot of memorization.